What is a toaster? A toaster is a device used to cook and heat up bread. It is common to a large number of households and can be found in a variety of shapes and colours. To use a toaster, it must be plugged in. Bread is then inserted and the slider is pulled down. This starts the toasting process. An interesting fact is that the knob found on the front of the device depicts the strength at which the bread is cooked, rather than the time it takes until the toast is done. When the toast is done, it will often pop up. As my toaster does not toast evenly, I like to turn my bread round mid-process. Once done, move the slider up and take the toast out. You can either apply butter while the toast is hot or cold, or eat it as it is. Overall, a toaster is a great device which makes quick and simple food.
Hi, my name is Yasin, and today I will present about an open-loop control system in the toaster. As we know, there is three basic components in the open-loop control system, which is input, process, and output. So what is the open-loop system? Let's see. The open-loop system is the one-way system that has no feedback to alter the machine operation. So what is the input? The input is the control action that applied to the system, and the output is the system reaction of the given input. The first thing that we need to know about the open loop control system is the input itself doesn't depend on the output of the system. So when we toast the bread in the toaster and we put the same input into it, the output can be more or less depending on some disturbance. The disturbance can be this and this.
So here is the timer-based toaster process. Bread is put into the toaster, a timer is set, and a lever is pushed down, acting as a switch to start the process. The toaster coils heat and stay heated for the time set on the timer. Then the toast pops up, coils turn off, and the process ends. And that is how a white bread turns to the tan bread. Enjoy your bread!
Hello, my name is Noel, and now I will explain about the closed loop system. Open loop systems are not very reliable because they're not able to handle the disturbance. So there are four main components of a closed loop system, which is the input, the controller, and process, lastly the output. So what is closed loop system? Closed loop systems are commonly called feedback control system. Feedback characteristic of closed loop system which distinguishes them from open loop system. It is the property of closed loop system which permits the output to be compared with the input of the system so that the appropriate control may be formed as a function of the output and input. In general, feedback is said to be exist in a system when a closed sequence of cause-effect relation exists between variables. Hence, what is the closed loop system in a toaster? Well, I give you an example of an automatic toaster.
So, this is what the automatic toaster looks like. So, assume that each heating element supplies the same amount of heat to the both sides of the bread, and toast quality can be determined by its color. The toaster initially calibrated for a desired toast quality by means of the color adjustment knob, and this setting never needs readjustment unless the toast quality criterion changes. When the switch is closed, the bread is toasted until the color detector sees the desired color. Then the switch is automatically opened by means of the feedback linkage, which may be electrical or mechanical.
This is an open loop system block diagram for the toaster. First, the input, controller, process, and output. As we know, first, An open-loop control system is a system in which the control action is totally independent of output of the system. In other words, the output has not effect on the control action. It means the output do not give any feedback signal that tell us how to vary the input to get the desired output. For this toaster, the output of this toaster will not affect to the controller or the timer. For example, when we set the timer 6 minutes and the toaster heat the bread till the timer stops. Even though the bread already burned, the toaster will still heat the bread because the output do not give any signal to the controller to stop. Second, the accuracy of the system depends on the experience of user. If is first time using this toaster, we need to do some experiment or try and error. For example, we try to set 1 minute and we see how the output, 3 minutes, how the output, and 5 minutes. So if we already do some experiment, we will get the accurate timer for the bread to get the medium brown color.
Let's proceed with the diagram block of a closed-loop system of a toaster. Compared to an open-loop system, a closed-loop system has a feedback path. You will also have time to experiment for a few times to know which value of the toaster should be to achieve the desired toast color, but in a closed-loop system, this is not the case. Let's start toasting the bread. Starting the toaster, you will start heating the bread. You will already have in mind what color of your toast should be. This is the input. While toasting, you are observing the color changes on the bread as it starts to toast. You are always comparing the color to the desired bread toast that you want. That is the comparator. The error signal is closing to 0. Coincidentally, as time goes by, the color of the bread in the toaster will be the same as the color of your preferred bread toast. The error signal is now 0 and you turn off the toaster. Voila! Now you have the actual toast quality and that is the output. But wait, what about the feedback path? The feedback path turns out to be you all along. You decide what the desired bread color is, hence the actual bread color. In a closed-loop system, the actual toast quality is predetermined by the sensor, so as it will always be the same as the desired toast quality. The error signal detected by the comparator is always changing so that the control time will not be constant, so long that the desired toast quality has not been achieved yet in the output. Therefore, a closed-loop system with a feedback control can handle variations in a system or compensates unexpected events.